You can be the absolute best senior software engineer in the world with a ton of experience. Someone who writes flawless, scalable, 10x code, whatever you call it, and still have a lot of trouble when trying to build AI agentic systems. And this surprises a lot of people, or at least it does to me. The thing is that traditional software development is deterministic, same input, same output, every single time. But AI agents are not like that. They are probabilistic by nature, and that difference forces a complete rewiring on how you think about logic, testing, and architecture in modern software systems. In this video, I will show you three things. First, why traditional logical thinking breaks down in the probabilistic world we are currently building on. Second, why by checks are quietly destroying agentic projects in production. And third, why the most successful agentic architectures are actually shockingly simple. And by the end of this video, you will have a mental model to stop building fragile AI-powered applications and start shipping real systems with confidence. So let's dive in. Agentic Non-Determinism. Software engineering has always been about control. You always know what will happen if an if clause is false and vice versa. In pretty much all programming languages, we work under the assumptions that the same input will give us the same output. Of course, there is some randomness here and there, but most of the enterprise code that powers our life, like financial systems or healthcare, are deterministic. But now, AI agents are completely changing the landscape. When working with LLMs, even if you explicitly set the temperature to 0, you can still see slight differences in output. Not because the model is random for fun, but because the system around it changes. Changes in formatting, changes in deployment, and so on. So, same input is often not the same in practice. I have noted that most engineers have a hard time working this way, because many times I have found myself trying to brute force the output of an LLM to fulfill my desires. I try regex, if statements, nested conditionals. I tried so many things, but it turns out it doesn't work. Apparently, we cannot hard-code intelligence. So instead, we have to design an environment where the agent is allowed to succeed. Here's an example. Imagine you are building a support triage agent. If your goal is to produce the perfect paragraph, you will fight the model forever. But if your goal is behavioral, you can engineer it. For example, you can classify the ticket into one of 5 categories, or if confidence is low, ask exactly one clarifying question. Then, if it matches an FAQ, propose the top solution and cite the source snippet. And as a 4th step, otherwise, you can route it to a human with a structured summary, issue, evidence, next action, etc. This way of thinking is achieved, in which we should stop forcing one exact output and start defining acceptable behavior under variation. So if you treat an LLM like a library you import in a programming language, you have already lost. You should treat it like a powerful but unreliable component you must engineer around, and evaluate them the same way. The evaluation crisis. Unit tests are great. I love them. They are fast to execute. They catch bugs, prevent regressions, and we have many mature and reliable unit test frameworks out there to work with. The problem is that unit tests were not designed for agentic systems. They do not catch bad tone in natural language, or hallucinated reasoning, or tool misuse, or pseudo regressions when prompts, models, or context changes. This is the evaluation crisis. Many teams fall into the same trap. They write prompts, their output looks okay, and they ship it to production. It is byte-driven development, and it is a production disaster waiting to happen, because agentic AI solutions need evaluation pipelines, the so-called evols. And to be clear, evols are not vibes with extra steps. They usually mean 3 layers. First, a fixed scenario set, or your regression dataset. Second, automated checks. Format, tool calls, validity, safety rules, latency budget. And third, model-based grading. LLMs as a judge is the most common, for things like relevance, tone, and completeness. In this setup, you use a high reasoning model to grade a cheaper, faster agent against explicit criteria. And you track performance across hundreds of scenarios, no 5 cherry-picked prompts. Because if we cannot ensure proper evols are in place, we will be guessing. The architecture trap. As an engineer, I love complexity. Multi-agentic systems, agents talking to agents, loops inside loops. The problem is that it is often catastrophic in production. Every agentic step adds up 5 to 30 seconds of latency. Not to mention the monetary cost of burning extra tokens, by the way. More steps also mean more failure probability. If each agentic step succeeds 95% of the time, a 10-step chain succeeds about 60% of the time. And that is 0.95 to the power of 10. So more reasoning can literally make your system less reliable. So let's pause for a second, actually count how many LLM calls are in your most complex agentic framework right now. Because if it is more than 3 and your application runs in the browser, your users are already gone. This is the hidden latency tax of agentic frameworks. Users lose focus after 2 seconds. And as a rule of thumb, if your agent needs 30 seconds to reason, it doesn't matter how smart it is unusable. In my experience, the best engineers learn this the hard way. They become minimalists. They replace 5-step reasoning loops with one clear structured prompt that works fast. They use type tool schemas. They force strict outputs. They measure latency consistently, and they keep the call count low on purpose. From prompting to orchestration. For most applications, the agent is never the system. It is a component. Most people get stuck optimizing prompts instead of designing workflows. Here is a useful analogy. An agent is like a new intern. Give them a 100-page manual and no tools, and they will fail. Give them a checklist and the right functions, and they will succeed. Real orchestration has 3 parts. First, accurate context. Second, actionable tools. Third, strict guardrails. Accurate context means RAG, that is scope, fresh, and permissioned. Actionable tools means functions that are typed, observable, and safe to retry. Guardrails means times out, budgets, policies, and fallbacks when the model is uncertain. Your job as an AI engineer or software engineer who works with the AI system is not only writing logic. It is about curating the environment for the agentic system so it can reason correctly, orchestrate tools safely, and delegate gratefully. Building agentic systems today is a system design problem. It demands data intuition, product sense, and engineering discipline. So here is the takeaway. Trade complex loops for measured linear workflows and focus on the environment, not just the prompt. And if you want to see how an spec-driven approach brings stability to chaotic probabilistic systems, check out the video right here and see you in the next one. Bye.